Okay, so correct. An algebraic expression is a mathematical phrase with at least one variable, okay? And adipogee is correct. A numerical expression, no variables, right? Okay. Now remember, an algebraic expression can have more than one variable. Numerical expression has no variables in it. Okay, some of you guys were asking questions about equations, and that's what we're going to start talking about today. All right? At the end of this lesson, I'm going to go back and review a few of the homework problems that were, I would say, challenging, but I feel like it wasn't beyond what we covered in class. Okay, so can I get somebody to explain to me the first problem? Now, listen, throughout the day, students have been getting the order wrong here. If you think about this one, everybody has been kind of nailing this one. Just because the word phrase has things listed in a certain order doesn't mean that the expression is in that same order. Okay? You need to understand what the word phrase is saying. Trinity, what's the first one?
4 more than y is y plus 4.
Very good. I had a number of students say 4 plus y. That's not what it's saying. It's saying 4 more than y. Okay? So y plus 4. All right, so the next one, Jason, could you take your jacket off too, please?
V minus 6.
Excellent. Very good. V minus 6. 6 less than v is v minus 6. And then this one right here, I've been getting pretty much 2 different answers consistently. Who can give me their answer? Go ahead, Nathan. K divided by 6. But for what we're doing in algebra and for the most part solving equations, we're not going to see the division symbol too much. We're going to see a lot of things in fraction form. Okay? And I think today when you see how I explain a strategy for solving equations, I think you're going to understand what I'm talking about. All right, so can I get a volunteer to read all the way through to my definition of open sentence? Jayla, go ahead.
What you'll learn to solve one-step equation using substitution, mixing math, and estimation. You will learn equations, open sequence, solution to an equation. While learning solving equations can help you find amounts that are not easy to measure on your own. For example, if you know the weight of the bucket, you can use this equation to find the weight of the
Orangutan. So let's take a pause right here. So has anybody here been in the National Zoo? Have you seen the panda, the baby panda? Is it Bebe or what's?
Oh, babies.
Okay. So now if you, please stop. If you've gone to see what they do in the panda exhibit, sometimes you might see them weighing the panda, and they actually put the panda in a bucket. Just like this orangutan they're putting in a bucket. Why do you guys think they're putting it in a bucket? Quinn. These are essentially babies. They're animals, but they're baby animals. They don't, right, so they don't want it to fall off or run off the scale, so they kind of put them in this bucket so they can get a good reading. But guess what? That's not the value they want, right? And can somebody tell me, why do you think they measure these? They do it pretty regularly. Why do you think they're measuring the weight of these baby, whatever it is, in this case an orangutan? Yes?
To make sure that they're getting proper nourishment or exercise.
Excellent. So I've heard a number of things throughout the day. Some people said to monitor their health. I think that hits it on the nail on the head. They want to make sure they're getting the proper amount of nourishment because they know that these babies should be growing a certain amount. But from day to day, they're not growing a terrible large amount, right? So we're talking about fractions of an ounce, okay? And you probably can't see it on this scale, but this scale has a decimal there. So if they're talking about very small changes in weight, the weight of the bucket is going to change, it's going to impact that measurement, right? So how do they fix that? How do they make sure that they get the weight of the animal and not the weight of the animal in the bucket? How are they going to do that? Kalila? Nice. If they know how much the bucket weighs, then what are they going to do with that value? They'll subtract it from the weight of the animal inside the bucket. Do you guys understand? Yeah. Okay, so if that's something you're interested in, maybe veterinarian science, you still have to have some understanding of math for many different areas and career fields, okay? So let's move along. I'm going to go ahead and finish reading this just because I hadn't made a video today. I want to make sure that we had this posted. An equation is a mathematical sentence with an equal sign, so pay attention to that. Yesterday we talked about algebraic expressions, but there is no equal sign, right? When we plugged in a value for the variable, then we showed what it was equal to, but it wasn't an equation. It wasn't an equation. Today we're talking about equations, okay? An equation with one or more variable is an open sentence. You will see that on a quiz or a test. You need to know that, okay? The open sentence, p plus 2 equals 16, is neither true nor false until we put in a value for p's, until we replace p with a value, okay? So that's an equation, but an equation is neither true nor false. But when we substitute for the variable, in this case p, then we determine is it a true statement or not. Now, what happens if it's a true statement and what happens if it's a false statement? Let's take a look at this some more. You can substitute a number for the variable in an equation to see if the value makes the equation true. A solution to an equation is a value or for a variable that makes an equation true. So if you take a look right here, do you guys see, here's my equation? And then for here, this is false, but what did I replace p with? I replaced it with 20. And what's 20 plus 2? 22. And is that equal to 16? No. That's a false statement. So guess what? 20 is not a solution to the equation. Do you understand? So I'm trying to get you guys to understand the terminology, okay? So that when you're reading a word problem or you're given some instructions on a test, you know what it's asking you. All right, so over here we have 14 plus 2. In this case, p is what? 14. And what is 14 plus 2? 16. And that is a true statement. So guess what we can say about 14? I heard it. It's a solution to this equation. Do you guys understand? Yes. Okay, so now that's what this says right here. 14 is the value for the variable p that makes the equation true. Therefore, 14 is a solution to the equation. So moving along, this example I just gave you, let's take a look at this problem right here. Solving equations using substitution. So you're going to find the solution of 12m equals 108 from the numbers 4, 7, and 9. You can test each number by substituting for m in the equation. So you're going to do basically what we just did, right? So can you guys just really quickly scratch these numbers out? And then if I can get a volunteer for 4, 7, and 9, who's got 4? Trinity, take 4. Who's got 7? Somebody I haven't heard from. Jeremy, could you get 7? And who can get 9? Quinn, can you get 9? So who gave me 4? Can somebody share with me their answer for 4? Who had 4? Trinity. What did you get when you substituted for m 4? And is that true? No, 12 times 4 is not 24. What is it? 48. It's okay. It's the end of the day. I know. I'm feeling the same way. I'm kind of beat myself. So 12 times 4 is 48, and that does not equal 108. So is that a solution? No. So that is not a solution to our equation. So who did number 7? Jeremy, what did you get for number 7? 72. And you guys got to work on that. 84. Come on. Do I need to give you guys the multiplication charts now? No. So 7 times 12 is 84. That's not equal to 108. So that is not a solution either. And who had 9? Come on, whoever's got 9. Who had 9? I got 108. 108. And that is the solution. That is true. So because when m is substituted with 9, we get 12 times 9, and that is 108, and that's a true statement. That means 9 is a solution to the equation. Questions?
Let's say we do like for problems, not a multiple choice problem, but the one that you have to actually fill out, and of all the answers that they give you, none of them are correct. You just put that it's not right.
You might. There are some equations that have no solution. So yeah, you would have no solution. Okay, Jayla? Much like this. Yeah. Go ahead.
What if, because I just do opposite operation.
Right, that's what I want to teach today. So this is kind of like introducing you guys from yesterday to today into equations. But I don't like that they want you to mentally solve things. So I'm going to talk about opposite operations. Very good. So we're going to get to that today. Kayla? I have some people that asked ahead of you, and I'm going to start letting people go in a little bit. Okay, so here's what you guys can do right now. These two examples, can you guys see that? Two equations. Each equation has 3 numbers to test. Can everybody see it? Okay, go ahead and get that done. And then, when she gets back. So everybody should work out all of these, but I'm going to assign a few people to do some. Laura, if you can do the 3 for the first one. Kalila, if you can do 5. And who can do 11 for me? Everybody's putting their hands down now. Joshua. And then for the second equation, can I get a volunteer to do 4 for the second equation? Somebody else? Tori, go ahead. And then somebody can do 6. Can somebody test 6 out for us? Who can do 6? Somebody I haven't heard from yet. Karis, can you do 6 for the second equation? Test that out. Okay, it's 124p equals 992. Can you test 6 out for us? And then 8, I need somebody to test out 8 for us. Kayla, go ahead, yes. Okay, so everybody that has those, get those done first, and then backtrack and do the other ones. Is anybody absent today? Who? Okay. Okay, let's go and get started. Who had number 3, the value 3 for the first equation? Go ahead.
I got 72.
Okay, and is that a solution to our equation? No. Nope, that's false. Okay, and who substituted 5 for us? Kalila, go ahead. Right, 120, and was that true? Yep, that was our solution. And who did 11? Go ahead.
I got 264.
264, and was that a solution? No. Nope. Okay, over here for 124p equals 992, who substituted 4 for us? Go ahead, Tori.
I got 496.
And is that a solution? Nope. And then who did 6 for p? Go ahead, Karis.
I got 744.
744, very good, and that's false. It's not a solution. And then last but not least, who did 8? And what did you get? Yes, 124 times 8 is 992. That was true. That is our solution to our equation. That was our solution to our first equation. I have a question over here. What's your question?
For the problems that we did on the previous page, we had the variable we filled in times whatever number that we had, and then we had the answer what it was, and then we put whatever was at the bottom. So it's supposed to be like 24 times 3 equals 72, and then underneath that it was 120.
Well, you could have shown this. Like I could have just said this equals. This is what we substituted, and this is what we show. And is it true or false? That's false, right? Okay, Adepoju.
Will these as well the quiz, like they'll give you 3 numbers to substitute with?
They might ask you that way. There's a number of different ways they can ask you, okay? So let's move on to the next part. Now listen, I know you guys can mentally solve these, but I'm trying to teach you today, starting today, I'm trying to teach you the strategy, and Talise mentioned it, opposite operations. So I know that you can mentally solve these, and some of these are a little more challenging than others. There's a handful that students were struggling with to mentally solve, but first of all, can I get somebody to tell me what their answer is? Can somebody share with me their answer for this first example right here? Dominic, what do you think the answer is for this first equation over here? Yes, so y equals 5. If you substitute for y 5, it works. 4 times 5 equals 20. Now, here's how I want you to think about this, because what I'm trying to teach you is a strategy that's going to work on single-step equations, two-step equations, multi-step equations. So in the homework, there were some algebraic expressions that were pretty challenging to factor, right? Okay, you can have equations looking like that. And so you're not going to be able to mentally solve those equations. So if you trust what I'm about to show you, that this is what is going to carry you through to the more difficult equations, then it's useful to start learning it now. So take a look at that equation. And some students shared with me that last year Mr. Foreman told you to isolate the variable. What's it mean to isolate? What's isolate mean? So isolate, if we're not thinking about it in terms of math, means to get by itself. So if somebody's in isolation, they feel like they're by themselves. Does that make sense? So we want to isolate the variable y. Now, in order to do that, I have to look at what's with y. On that side of the equal sign, the left side of the equal sign, what's with y? That's on the other side of the equal sign. On the side with y, what's over there? 4. And it's not just 4, it's 4 what? 4 times y, right? So how do I undo 4 times y? What's the opposite of 4 times y? Right. So if we divide by 4, that's the opposite of multiply by 4. So take a look at this. Do you see what I just did? And I can't just divide by 4 to one side because it's an equation. So I have to do the same thing to both sides of the equation so that it stays balanced. So now if you look at it, I have the fraction 4y over 4. And then I have the fraction 20/4. Well, you guys know how to simplify 20/4. What's 20/4? 5. And we already talked about canceling or simplifying. What's 4 divided by 4? 1. Or you can just cancel out and say that I have a 4 in the numerator, 4 in the denominator, so they go away. But I get up with 1y equals 5. And we know that if we multiply anything times 1, what do we get back? The same thing, because that's the identity property of multiplication. So that's my answer. And I know that looks like a lot, but I'm trying to set you guys up for what you're going to see in pre-algebra, algebra, and beyond. Okay? So it's not very useful to try to mentally solve these problems. I'm trying to teach you something that's going to help you out in the most difficult equations. There's operations you guys haven't even seen yet. So in calculus, there's 2 operations that you learn in calculus. It's called differentiation and integration, and they're opposites. Okay? Integration, differentiation, and they're opposite operations. Okay? So we're not going to explain that right now, but I'm just telling you there's operations you haven't been exposed to yet. And if you think about using opposite operations, that thinking applies now at the most basic level. So I'm trying to get you guys thinking in a certain way so it'll carry you through all the way. All right, so over here, who's got this answer? Jason, go ahead. 8.5. Nice. So Jason's correct. He said 8.5. And if we think about this as opposite operations to isolate variable m, what's on the side with m? 7. Not just any 7. What kind of 7? Plus 7. I'm adding 7. So the opposite of add 7 is what? So I'm going to go ahead and I'm going to subtract 7 from both sides. Got it? Now, when I do that, something a little differently happens here than what I did with divide by 4 on the first problem. What's plus 7 minus 7? 0, right. And then, like Jason said, 15 take away 7, that gives me 8 and 5/10, right? But now, what's m plus 0? Don't say 0, please. It's just m, because if I add 0 to something, I don't change it. So I just get m equals 8.5.
I don't get it.
Where did I lose you at?
We use the -7.
Because I'm trying to do the opposite of plus 7. So I'm going to -7 here, and I got to do the same thing to both sides. -7 and -7. So I can't just subtract 7 from this half of the equation. I got to subtract it from both halves. And what did you get? What was your answer when you subtracted 15 and 5/10 from 7?
I didn't understand it.
So are you disagreeing with the answer or agreeing with the answer?
I'm agreeing with the answer.
Now, this is what some students made a mistake on. They forgot that if I don't have a decimal, I put a decimal here. Okay? I had a number of students forgot that. So when a student gave the correct answer, 8 and 5/10, a number of students are like, what? How did that? But when I showed them that, they're like, oh, okay, I see what's going on. So the way to think about this is on an equation, there's two halves. There's this side and there's that side. So take a look up here. The side that has the variable is the side you want to get the variable by itself. Okay? So here on this side had 4m plus 7, right? I don't want m plus 7. I just want m over here. So I need to get rid of what's with the m, and there's a plus 7 there. Well, what's the opposite of plus 7? -7. And so I can't just -7 from one side. I got to -7 from both sides. And so this becomes 0. But this became our answer, 8 and 5/10, and then m plus 0 is just m. So there's my final answer right here. Over here, the opposite operation was divide. Instead of multiplying by 4, we divided both sides by 4. And we did that to both sides. So here, the operation that was opposite was divide by 4. Here, the opposite operation that was opposite was subtract 7. OK, so what I want you to do now is go ahead and solve these. Yes? Yeah, that's what we just did. We subtracted 7.
Can you go up a little bit real quick? Because I didn't. Okay.
All right, 4 more problems. Let's work these out really quickly.
When she comes back,
Can I scroll down? Are we good? Who can walk us through the first problem? Jayla, go ahead. You added 3 to both sides, so 7 plus 3, and that gave you back what? So Jayla's correct. Over here, on this side, the equal sign, I got t minus 3, right? And so I don't want to have t minus 3. I want to have just t by itself. So I got to get rid of minus 3. How do I get rid of minus 3? I'm going to add 3 to both sides. Now, when I add 3 to both sides, minus 3 plus 3 becomes what? 0. And then 7 plus 3 becomes 10. Are we good? Over here, this is very similar to the second problem we just did. Who's got this one? Nicholas, can you walk me through this one? What do I do? This one threw a lot of people off. I'm trying to see if maybe it clarifies some things. So Nicholas, let's walk through this. Take a look. I got n plus 6, right, on this side of my equation? Nice. That's exactly right. So Nicholas just said I'm going to subtract 6 from both sides because I need to do the opposite of add 6, right? And then Nicholas, what happens to plus 6 minus 6? What's that going to become?
0.
Right. So then on this side of my equation, I got n plus 0. But then over here, what's negative 10 and 1/10 minus 6 going to be? They're same signs, so remember what we do. Do you want some help?
Would that be positive?
Well, you're going to add the numbers,
Oh,
keep the sign, right?
16.1, negative 16.
Nice. Very good. Okay. And then now we want to get rid of that 0 because n plus 0 is just going to be n. So n equals negative 16 and 1/10. Very good. Okay. Any questions about that problem? Okay. It's going to take seeing these a few times before you get more comfortable with this method. Some of you guys sound like you already know the method. I'm trying to get a head start because we have a lesson on this. We have 2 lessons on this coming up. So I'm trying to get you guys thinking already along those lines. Okay, can we take a look at this next problem over here? Who wants to talk about this problem? Quinn? Okay, so what am I doing here?
The 8 and 4 one?
Uh-huh.
Okay. Well, what you have to do is, so you have to divide, no, you have to multiply.
Very good. So I have divide by 4, right? So to get rid of divide by 4, I got to do the opposite. So what's that going to be?
Multiplication.
I'm going to multiply by what?
You have to multiply the 2.2 times 4 and the 4 times.
All right, so take a look at how I multiply both sides by 4. Please put away the notes or whatever it is, the drawing. Put it away. Okay, so look at this. Here's what we got. Do you see why I'm multiplying by the fraction 4 over 1 on one side, and I'm multiplying by 4 on the right side? Do you see that?
Yeah.
I'm multiplying both sides by 4, but one side is a fraction equivalent to 4, and the other side is just 4. Right? Why did I do that? Quinn, why? Why did I do that?
Because then you can cross divide.
Right, because there's a couple things that happen. You guys know that you can cancel out, right? Because the 4s go away. And so this 4 goes away, cross-canceling. And then I'm left with just h over 1. And what's h over 1? It's just going to be h. And then 4 times 2 and 2/10 is what? 8.8. Are we good? All right, and who can get this last problem for me? Somebody, Tori, go ahead. Oh, what's the question, Tori?
I don't understand how you multiply. I understand how you multiply since it was opposite.
Uh-huh.
I don't understand, so turn it into multiply and then
Well, I'm multiplying the same thing to both sides. This is 4 over here, and this is 4 over here. I'm doing the same thing to both sides again, right? But, so do you understand this step, why I'm multiplying 4 to both sides? Okay, and do you understand that 4 over 1 is the same as 4? Does that make sense? So, are you confused about how this goes from here to just h? Okay, so watch this, I'll work it out. So if you have 4 over 1, and you're multiplying by h over 4, we know when we multiply, we just go straight across, right? So that's 4h. And then 1 times 4 is just going to be 4, right? Well, anytime you have a numerator and denominator, they're the same thing. That's just the same as 1h or h. So do you see how we get to h now? Okay. Yes?
I did it differently for the H.
Did you get the same answer?
Yeah.
Okay. We're not going to go off on the many different ways because I'm trying to get to a certain point today. If we have time, we'll come back. Adipoji, what's your question? Go ahead, walk me through it.
I divided negative 63 by 7.
Okay, so because I'm multiplying by 7 here on the side with the x, to get rid of the 7, I got to divide by 7. Wherever that is. There it is. And when I divide both sides by 7, what happens to this 7 over here? Tori, do you know how we're going to handle this? It's just like my last explanation. What's going to happen to the 7s?
The sevens, they're
Right. So then I get 1x, and 1x is just going to be x. And then adipogee, what's going to happen with negative 63 divided by 7? It's going to be a negative because you have different signs. When you multiply and divide different signs, the answer sign is going to be negative. Okay? Are we good? Okay, so there's a lot of review of what we've covered this year. A lot of it's coming back. You're going to use all these different things to problem solve more advanced things. Okay. I will put these in the notes. So if you didn't get this, I'm going to move on to the next thing, which is let's go ahead and estimate. You can solve problems by using equations and estimation. Estimating solutions. A veterinarian holds a puppy and steps on a scale. The scale reads 134 and 5/10 pounds. The veterinarian weighs 125 and 4/10 pounds alone. Which is the best estimate of the weight of the puppy? So think about this. Instead of the bucket, what are we using? We're using a person. The veterinarian is hopping on the scale with the puppy, right? And that's how he's weighing the puppy. Because he knows how much he weighs. He weighs 125 and 4/10 pounds. So what you need to do is you need to give me an estimate. How are we going to estimate this? How much does he weigh with the puppy about? How much about? About 135. And then about how much does he weigh alone? About 125. So what are we doing? Adding, subtracting, what are we doing? We're going to take the difference, and what's the difference going to be? 10. So that means the puppy weighs about how much? Make sure you're labeling your units. I can't tell you how many people are still losing points because they're not putting their units on their test questions. Please start labeling it. Those are easy points, ladies and gentlemen. Okay, moving along. Can we go ahead? That last one was finding the difference to get your answer. This one, it's a different operation altogether. There's two ways to think about this. Read the questions to yourself and try this on your own. So I did the first one with you. Now I need you guys to try this one on your own. And then I'll take a volunteer who wants to walk us through it. Talise? Uh-huh. Yeah, both of them are estimation. Mm-hmm. You don't need the exact amount. Do you have a question? I'm going to try to get somebody else to answer this one. Unisa, are you done? Do you have a guess on what you would do? Kayla, what do you think?
Well, I rounded 14.7 pounds up to 15 pounds.
Nice. Yep.
And I divided 390 by 15.
Yeah, so you took 390 and you divided by 15.
And that's 26. But it says about how many can it have at one time. And it said the weight limit that's the weight limit. And
Right.
since we rounded up, it'd have to be 25 because it can't have more than that.
Oh, no. The box is actually less than 15. So your thinking is right, but you just got to flip it. So you rounded up, so that means it's a little bit less than the weight limit, so you're okay. Because I understand what you're saying. Like, you don't want the forklift. I used to drive forklifts. That was my high school job when I was in high school. And I was the only guy working in the warehouse that was not an adult. Everybody else was like 20-something. And I liked the job. You want to know why? I felt like I was driving a go-kart with like remote controls. It was like a video game to me. So you know what a forklift is, right? Yeah. It's got like the metal, what are called forks. And what I did was I would show up to work, and I loved it. I didn't have to deal with a lot of nonsense. They would say, hey, my name is Rob. Hey, Rob, we got a truck that came in. Can you unload this truck? And then split up everything to their departments. So I would go to the truck with my forklift, and I'd unload with the forklift the pallet of goods. And each pallet was like a different department. So I'd go take it to different parts of the warehouse. And then people would go take their merchandise and put it on the shelf. And that's what I did. I just drove this, there was like buttons for the forks to move them and adjust them. So it was like a live video game to me. And I was thinking to myself, I'm getting paid to sit on my bottom and just drive this thing around like a go-kart. I loved it. But here's the thing, and this is what reminds me of that. If you overstack your forklift, you can have it tip, and that thing weighs a lot. You could kill somebody with that if it fell on somebody. So, just something to think about. I like what you said. You don't want to overload it, but that's why you have to be careful with things. So math is important for a number of reasons. That's just one area where you have to be careful. Now, let's take a look. The value of a variable that makes an equation true is called the what of the equation? Who's got this? What is it? It's the solution, right? The open sentence 14k equals 0 has blank solutions. Has one solution, right? Tell whether each value of the variable is a solution of the equation. So if I substitute -7 here for x, is that going to be a true or false? True. That's true. So is that a solution? Yes, that's a solution. What about here? If I substitute for y6 into this equation, 8 minus y equals 2, is that true? Yes. That is true. So that is a solution. What about over here? If I replace b equals 4 for the equation -7 plus b equals 4, then is that going to be true? No. What does it end up being? -3, right? And -3 does not equal 4. That's false. That's not a solution. Okay, so over here, what would this be? What would the solution be here? -9. So here's how we'd work it out. I need to isolate my variable m. I need to undo multiply by 10, so I divide both sides by 10. And then 10 divided by 10 is what? 1. So I get 1m, but -90 divided by a positive 10, what's that give me back? -9. And so m equals -9. Over here, what do we get for this one? Now, some of you guys got it. -3. Look, this 6 doesn't have a sign, so what kind of 6 is it? Positive. So if I subtract 6 from both sides, positive 6 minus 6 is what? 0. So I got 0 plus w equals -3. And then 0 plus w is just w, so w equals -3. Are we good? Okay, over here, I wanted to kind of review something with you guys. Do you guys remember reciprocal? Yes. What is the reciprocal? It's when you take, so what would the reciprocal of 40z be? Z over 40. And there's something else the book said about reciprocals. If you multiply reciprocals, you always get the same result back. What's the result going to be? So let me give you an example. 1/2 times 2 over 1, what is that? It equals 1, right? It ends up canceling out and becoming 1. So if I multiplied this by the reciprocal, this would become 1 on the left-hand side. And then z to 8z over 40 simplifies to 5z. Okay? And then now I'm dividing by 5. So to get rid of 5, I'm going to multiply both sides by 5. And then what I end up with is 5 equals z. Okay? This last one's pretty easy. I need to do what to get p by itself? Divide by? Not 5. -5. Divide by -5. Okay? And then -5 divided by -5 is what? It's 1. Remember, a negative divided by negative, same sign's positive. And also, I've also been saying all along, if you divide by the same thing, it's 1. So 1y equals -4 because positive 20 divided by -4. And then y equals -4. Okay, now really quickly, I want to go back to the homework. And I felt like you guys were kind of like, okay, this makes sense. I understand this. And I just want to make sure that if you didn't, that you can see how the lesson applied to what we were working on. Please stop with the banging. Now, over here in the numerator, what is the GCF of 6x and 4? It's going to be 2. So let's rewrite this. I have 2, and in the parentheses, what am I going to have in the parentheses? So 6x divided by 2 becomes 3x. And then 4 divided by 2, the factor we pulled out becomes what? 2. It's a plus 2. Now, you should notice that we have 2 things we can get rid of, right? I have this 2 and this 2. Those go away. So I have my answer, which is going to be 3x plus 2. Now, why are we learning this? I'm going to tell you why we're learning this. Sometimes you're having an equation. So you're learning single-step equations. But sometimes your equations look like this. And you have to kind of see if you can get rid of things to make it look a little easier for you. Okay? So we're trying to learn a couple of things because it's all going to go towards us solving equations. Yes?
So can you just like divide 2 by 6, divide 2 by 4, then that gives you the answer?
You could, that involves fractions, but I was trying to tie this in with reverse distribution. Okay, so there's more than one way to do this, but there's some situations where the only way is for you to factor or to do opposite of distribution property. Got it? Please stop with that. Put it away. Now, over here, what's the GCF of 15 and 36? I'm hearing 3. I agree with you. So in the numerator, what would I have? This 15 on the inside is 5, and then 36y becomes 12y. And in the denominator, I got 3. And then we see we have something in common, and it's not always going to be like that, but this is just the book's trying to be nice. So here, that goes away. And then this simplifies to be 5 plus 12y, but typically in algebra, we like to have the variable in front, so 12y. And then 5 doesn't have a sign, so it's plus 5. Okay? Now, this one's very similar to what we did earlier. I'm not going to rehash. I feel like that one's similar to the first two. But this one I thought was pretty complicated. That one, you guys are never going to see one like this, so we're not going to work on that one. But I do want to work on this one right here. Now, this one wants us to simplify. So first of all, we're going to do distribution property. That goes here, right? So if I distribute that, I have 2/3, and I need to multiply that to my first term, which is going to be 8x. Okay, but then I also need to multiply it to my second term, which is going to be 12. But hold on a second. I still have this minus 4/3 I got to deal with. And then in order for me to multiply these, I have to fix something, right? These aren't fractions. 8x and 12 aren't fractions, right? So let's make them into fractions, and we know how to do that. How do we turn them into fractions? Very good. You put them over 1. So let me go ahead and put these over 1. I should have done that in black. Okay, so when I multiply that out, let's simplify this. What do I get back? This becomes, what does this become? 16x over 3. Don't simplify this because you're going to have to undo your hard work. 12 times 2 is what? 24/3. And then I have minus 4/3. Do you see why I didn't want to simplify that fraction? Because now they all have a 3 in the bottom, right? And so now I have this all over 3, 16x plus 24, and then minus 4. Is there something else I could do here?
Yes.
What can I do?
You can minus 24.
I got the 24 and the minus 4, right? So what do I end up with in the numerator? 16x. What happens to these two? It's plus 20 over 3. And I would say that that is your answer, but you could go one more step. I could say, you know what? I'm going to rewrite this. 16 and 20 have a GCF. What's the GCF going to be?
4.
I could bring out a 4. So I got 4. And what's going to be inside my parentheses? 4x. And then this becomes a what? Plus 5. And you're pretty much done with your answer. If you want to clean it up a little bit, you can. You can rewrite it like this. 4/3, 4x plus 5, and then you're done. Okay? And that is the end of the lesson. That was today's homework? I thought that was last night's homework.